Once again, good morning to everyone, and now we will do the exercise 6.1. Whatever the theory we have already learned so far, all these theory we just have to apply in the exercise 6.1. Okay, so let's see how the students you have remembered how much things. Okay, so first it is given that all circles are dash. All circle means the circle may be this one, otherwise it may be this one, otherwise maybe this one it is the circle, otherwise this one it is the circle. See, amongst all the circle, here it is given that all the circle. So amongst these four taken circles, one thing it is common. It means their shape it is same, but their size it is not same. So for which we can call it as the all circles are similar. Why? Because all the circles having compulsorily the same shape. Any figures having the same shape but not necessarily the same size, it is called as our similar figures. Ready? And the next one it is our all squares are what? All square. Square means maybe this one, otherwise maybe larger size, otherwise this much size. So for which one thing it is common that the squares having the same shape but not necessarily the same size. So for which this one it is also our similar. All squares are our similar. Next one it is given all which triangles are similar. All which triangles are our similar. Just see, all which triangles are our similar. See, suppose I am showing you the examples first of the isosceles triangle. Here it is isosceles triangle. Suppose one may think that isosceles triangles are similar. Here I am showing you the isosceles triangle. See, here it is one isosceles triangle. Here it is another isosceles triangle. Suppose this angle it is 80. 80 means isosceles means these two angles must be same. As this one it is 80. So for which this one it is our 50 degree. This one it is also our 50 degree. This one it is the isosceles triangle. But here it is also isosceles triangle means this angle. Suppose I am taking it as the 100 degree. So it means this one it will be 40 degree. This one it will be about 40 degree. So can I say that the both the triangles having the same angles, the corresponding angles are same? Can I say that in the isosceles triangle whether the corresponding angles are same? As the corresponding angles are not same, otherwise very less probability that the corresponding angles of the isosceles triangle may be sometimes may be same. So for which always which criteria it is to be satisfied? So for which always in the isosceles triangle we cannot call it as the similar. But whenever we are choosing it as the equilateral triangle, one thing it is seen. So it is 60, 60, 60. Equilateral means all angles 60. Here it is also 60, 60, 60. Suppose here it is 3, 3, 3. Suppose here it is 10, 10, 10. Whatever the side it may be, always one thing you can find from both the equilateral triangle, their corresponding sides, having the same, corresponding angles having the same measure. Also corresponding sides also are in the same ratio, otherwise in the proportion. So for which in the equilateral triangles are always similar. Next question it is given that two polygons of the same number of sides. The two polygons, actually the polygon to be similar, 100% both of them having the same side first. Here it is two polygons of the same number of sides are similar if their corresponding angles are, whenever the two polygons are similar, their corresponding angles are equal. Corresponding angles are equal and corresponding sides are in same ratio, otherwise in proportion. Ready? Whatever this one, it is the direct definition. Direct definition, the two polygons are to be similar when their corresponding angles are equal and their corresponding sides are in the same ratio, otherwise in the proportion. Okay? Next question it is given to give two different examples of a pair of similar figures. Sorry. Here it is given that two different example of the pair of similar figures. See, this one, we can call it as the similar figures. This one also we can call it as the similar figure. Also we can call this one, also this one we can call it as the similar figures. Understood or not understood? Then it is given that give two different examples of the pair of the non-similar figures. See, non-similar figure. This one it is the circle. This one it is the triangle. Can I call both the figures are the similar? As both of them having the different shape, also different shape. So for which we cannot call them it as the similar, for which both the figures are the non-similar figure. Otherwise this one it is another example. This one you can take with the this one also, square triangle. Otherwise this quadrilateral with the this quadrilateral parallelogram. Okay, and also square also you can take with the rhombus also, rhombus. Okay, so these are the few of the examples where the pair of the figures are non-similar figures. Okay, and here it is another question. Question number 3 it is given. Here it is one of the quadrilateral and here it is another quadrilateral. You just have to say whether both the quadrilaterals, otherwise commonly you can call it as the polygon, or also it is the four-sided, for which I am saying it as the quadrilateral. Whether both the figures are similar or not. Whether both the figures are similar or not. So to be similar, two conditions it must be satisfied. So first one it is our corresponding angles are same. See, here it is the 90 degree, but this one it is not the 90 degree. This one it is not the 90 degree. This one not 90 degree. Also this one it is not the 90 degree. Actually from the beginning it has failed. But another criteria I am checking. But I know that another criteria no need to check. But I am checking for your self-satisfaction. Okay. See, here it is the corresponding ratio are 1.5 divided by 3. 1.5 divided by 3. Here it is 1.5 divided by 3. Here it is 1.5 divided by 3. Here it is also 1.5 divided by 3. Everywhere you are getting this one it is half, this one it is half, this one it is half, this one it is half. So it means corresponding sides are in the same ratio, otherwise in the proportion. But first condition failed. But first condition it was, our first condition it is to be corresponding angle it is to be same. But here it is corresponding angles are not same, but the corresponding sides are in the proportion. But to be similar, two conditions must be satisfied. As it is failed to satisfy the one criteria, otherwise one condition out of the two, so for which the figures both the quadrilateral we cannot call them it as the similar figures. Understood or not understood? Okay, so in the next time we will do the discussion regarding our similarity of our triangle. Okay, thank you. Have a beautiful day ahead.